Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over section 3.15b of our virtual calculus text on implicit differentiation. We're going to look at how to differentiate implicit functions with x and y mixes. A depiction of the type of problem we're going to cover is given here. We are to find the derivative of the given function 5x plus 3y cubed equals negative 5xy squared plus 3. If this is the kind of problem you're looking for, don't forget to hit the like and subscribe buttons. We have 4 practice problems at the end of this presentation that I would like you to try out in order to gain mastery, to demonstrate mastery of the content of this tutorial. Alright, so the instructions for the examples that we're working on are as follows. You have to find the y dx of the given functions, of the given equations. All right. Okay, number one, let's say we have the equation 5x plus 3y to the third equals negative 5xy squared plus 3. All right, so let's go ahead and differentiate this. Now the first question is, how do you know to use implicit differentiation? We can see that implicit differentiation is the method of choice here because this is not an explicit equation in terms of y. All right, so think about implicit as not solved for, is not solved for y explicitly. All right, so not solved for y explicitly. For y explicitly, what does that mean? If it's not solved for y explicitly or isolated, that means that you use implicit differentiation. Okay? Sometimes you can easily solve for y, but in a case like this, it's extremely difficult to get y isolated, so the optimal choice or route would be to use implicit differentiation. Okay, so we have this implicit equation, 5x plus 3y to the third equals negative 5xy squared plus 3. And we are differentiating with respect to y. I mean to x, sorry. So we want to find ddx of this equation. So if you're looking for a derivative with respect to x, that basically means that we're paying attention to terms and checking out to see if they are in agreement with x or not. Okay? So whenever you hear the word implicit differentiation, think about agreement. So implicit differentiation, think agreement. Okay? So let's illustrate what we're talking about here concerning agreement. Any term that's a function of just has x in it, that has x as the only variable, that's a term that's in agreement with what you're differentiating with respect to. If a term does not have only x as a variable, it has x and another variable in there, you're going to have disagreements. And whenever you have disagreements, you have to reflect that by applying the chain rule and adding on d of that variable dx, okay? So let's look at the 4 terms we have here. The first term, clearly, we have the only variable here is x, so we have agreement. This one is not x, it's y, so disagreement. This one is a mixture, a disagreement. Remember, you can have only x, okay? And then this guy right here is, you can assume it's x to the 0th power, so it's an agreement, all right? All right, so let's go ahead and differentiate implicitly and talk about the idea of agreement. Now, when you differentiate 5x, this term is an agreement, so it's going to be just 5, applying your differentiation techniques. There is an invisible dx here if you apply the chain rule. So you see the agreement, when you have dx, it cancels out. All right, so you don't need to add that component. Just differentiate the term freely if it's in agreement. But the next term, 3y to the third, is not in agreement. So how do we reflect that? Just differentiate this as you normally would. if it were x. So if you differentiate this using the power rule, you have 9y squared. To illustrate disagreement, you have to add on d of that variable dx. Is basically the chain rule here. Okay, and then we're gonna go over here, and we have disagreement when we're differentiating this piece right here. So how do we differentiate negative 5xy squared? Well, to find the derivative of that, we can use the product rule, since we have the product of two variables. Okay, so this is how we're going to do it. Let me put it on the side here. So we have negative 5xy squared. So I'm going to group the first two together, and I'm going to call that u. And then the second two, I'll group them together and call that v. All right, we're going to use the product rule. So the product rule is vu prime plus uv prime. All right, so v is y squared, v u prime, negative 5x prime, vu prime plus uv prime. U is negative 5x, and then v prime is, we're going to be looking for what are we going to be looking for? The derivative of v, which is y squared. So we want to find the derivative of y squared. So using the prime notation, you could use ddx, okay, but I'm using the prime notation here, so it looks nice. And then what is the derivative of 3? Is a constant, so that's just 0. All right. So when differentiating these right here, let's talk about agreement again. This prime means derivative with respect to x is ddx, so this is agreement. And this one, there's no agreement there. Okay, so let's keep on going. We have 5 plus 9y squared dy dx. Okay, and over here we have y squared, and then the derivative of negative 5x is just negative 5. Since we have agreement, just differentiate it like that. And then bring down negative 5x times the derivative of y squared is 2y. Now, since there is this agreement, you have to add on dy dx. Okay? Just to illustrate the disagreement. All right, let's make it look pretty, and then we're going to simplify. So 5 plus 9y squared dy dx equals negative 5y squared minus 10xy dy dx. All right, so what we're going to do now is we're going to collect all the terms with the dy dx component to it to the left side and everything else on the right, okay? So we'll have 9y squared dy dx, and then our negative 10xy will bring it to the right side. It becomes positive plus 10xy dy dx. And then minus 5y squared, and then you subtract 5 from both sides, minus 5. Alrighty, now we're going to proceed to factor out dy dx from these two terms on the left side so that we can isolate dy dx. 9y squared plus 10xy, and then factor out dy dx equals negative 5y squared minus 5. And then to get dy dx by itself, we're just going to divide both sides of the equation by the coefficient of dy dx. So that's 9y squared plus 10xy. And 9y squared plus 10xy. Alright, so this divides out, and that results in the isolation of dy dx. And that's our final answer. Dy dx is equal to negative 5y squared minus 5 divided by 9y squared plus 10xy. Okay? All right, we're going to do one more example, and then we'll give you an opportunity to try out some practice problems. All right, for number 2, let's say we have the following equation. 4x to the third equals negative 3y squared minus 3x to the third y to the third plus 4. And we want to find dy dx, okay? You can clearly see that this is a problem where we are going to use implicit differentiation because y is not solved for explicitly. So 4x to the third equals negative 3y squared minus 3x to the third y to the third plus 4. We're going to be looking for dy dx, right? So to find dy dx, we're going to differentiate with respect to x. So now, remember when you're working with implicit differentiation, you think about agreement. All right, so d dx basically means we're looking for agreement with what? Agreement with x. Alrighty. Any term that has any other variable other than x, there's going to be a disagreement. So you have to add d of that variable dx when you're differentiating that term. All right, so let's take a look at what we have. This has only x as a variable, so we have agreement here. This doesn't have x at all. It has a y, so disagreement. This has a mix, so it's automatically disagreement because this y causes disagreement. And this is a constant. Constants agree with everything, right? Because you have 4, you can just add x to the 0 on there, and it's still the same thing as 4, right? Okay, so let's go ahead and start differentiating, paying close attention to agreement. 4x to the third is 12x squared. We have agreement there, so we are done with that. For this guy right here, we do not have agreement, so we are going to differentiate first, negative 6y, and then to reflect the disagreement, we're going to add on dy dx. Okay, for negative 3x to the third, negative 3x to the third y to the third, let's differentiate that. But this minus, most students make mistakes with this minus when they're differentiating a mix with a negative. So I'm going to show you something to do to help you avoid making mistakes, okay? So just add the opposite. Add the opposite of this. So I'm going to have plus. The reason why I'm adding this is I want to group the first two. I want to group the sign with the x, okay? So plus, we're going to be differentiating negative 3x to the third y to the third prime, all right? Plus the derivative of 4, which is 0. Okay, so I included this step so we can do this. This entire term here is a u, and this is a v. Okay, so we're going to use the product rule. Okay, so we have 12x squared equals negative 6y dy dx. Okay, and then if we differentiate this plus, you have vu prime, so v is y to the third plus vu prime, the derivative of u is going to be negative 9x squared. All right, so when you're differentiating u, there's agreement, okay? But when you're differentiating v, there's not agreement. So vu prime, let's indicate what we have. This is v u prime, that's the product rule, plus uv prime, right? Okay, so u is what? U is, so plus u, which is negative 3x to the third. That's u, and then v prime is, differentiate that, y to the third, that's 3y squared, but since there's disagreement, you add on dy dx. Okay, so that's uv prime, vu prime plus u v prime. Okay, now let's just simplify, and then we can finish it off by collecting all the dy dx terms to one side. If not, and then get it isolated. So we have 12x squared equals negative 6y dy dx. And then simplify this, minus 9x squared y cubed plus, well, that's no longer a plus. If you distribute the sign, you have minus 9x to the third y square dy dx. Okay, so all the terms with dy dx's, let's see what we want to do here. How about we have all the terms with the dy dx's on the right side, since it's already on the right. All right, so we're gonna, let's see, we have 12x squared. This is one of the terms without dy dx. Which other term? This term right here doesn't have dy dx, so we move it to the left side, plus 9x squared y to the third. And the terms on the right with dy dx's, we're going to factor out dy dx's while we are at it. So negative 6y minus 9x to the third y squared. Factor out dy dx. Okay. All right, and then the last step, we'll just basically divide both sides of the equation by the coefficient of dy dx, that expression there, that quantity. All right, so divide both sides of the equation by negative 6y minus 9x to the third y cubed, y squared, and negative 6y minus 9x to the third y squared. All right, so divide this out, and that will give us dy dx. We'll have, what do we have? Dy dx, let's change the color of that. Dy dx is equal to 12x squared plus 9x squared y to the third, all over the coefficient, negative 6y minus 9x to the third y squared. Okay, now we can simplify. If you notice, we have a greatest common factor with the coefficients. So what we do is we can just divide everything by, divide all the coefficients by 3. 3 is the GCF, right? We could do that. Or let me just show you what I'm doing. So we can have dy dx is equal to 3, factor out 3 from the top. You have 4x squared plus 3x squared y to the third. Okay, and then in the denominator, you can pull out another 3 also. 3, and then you have negative 2y minus 3x cubed y squared. And then you notice you can divide that out, and that will leave us with our final answer. Dy dx equals 4x squared plus 3 x squared y to the third. That divided by what? Negative 2y minus 3x to the cube y to the second. And that, ladies and gentlemen, is the answer to question number 2. All right, now it's your turn to do some practice problems. Alrighty, ladies and gentlemen, here are the 4 practice problems. So I'd like you to pause this video presentation at this time and try out these 4 practice problems. So number 3 is negative 5xy squared. And try out these 4 practice problems. As soon as you're done, click on the playback button, and we are going to reveal what the correct answers are for you to check your work. Welcome back. All right, let's take a look at what the solutions are. So for the first one, dy dx is equal to negative 3 negative 3 minus 9x squared y to the third divided by 9x to the third y squared plus 5. Number 2, the derivative is 4 plus 3x squared y divided by negative 12y squared minus x to the third. Number 3, the derivative is negative 5y squared minus 4x divided by 10y plus 10yx. And then for number 4, dy dx is equal to 5 plus 5y to the third divided by negative 15xy squared minus 1. Okay, ladies and gentlemen, how well did you do with these practice problems? Let's know how well you did in the comment section below. And if you have any questions, let us know, and we will be more than glad to support you. Thanks so much for taking the time to watch this presentation. If the contents of this tutorial helped you in the study of implicit differentiation, do give us a like or thumbs up. And don't forget to subscribe to our channel for updates to other great calc tutorials such as this. Tons of support resources can be found at mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.